Today, I'm going to talk to you about unified security activation, and let's get right to the demo. What you're looking at here is a unified console for endpoint security here at BlackBerry. We like to talk about the fact that we're cloud-enabled, but not cloud-dependent. And so you'll notice that the management console that I'm showing you here is hosted from a URL up in AWS. We're going to come back to the console, but first let's take a look at that activation. I've got another system here. Just pretend this is a corporate-issued device. It could be a personally owned device as well. We try to keep things simple here at BlackBerry, and we provide installers that can be delivered using any software distribution mechanism you desire. I've actually already gone ahead and staged the installer sitting right here. So let's go ahead and get that installation started. As I'm working through the installation, I'm also going to show you a little bit, or talk to you a little bit about the agent itself. The agent is extremely performant. If you think about what we're doing, we're leveraging artificial intelligence and machine learning to be predictive and preventative. And what that means is that we're going to evaluate activity on the endpoint and make a determination as to whether that activity is safe or unsafe. If that activity is unsafe, we prevent its execution, for example, if it were a binary, or stop the activity altogether. Again, the idea is to be preventative in nature. Now, what that means for us is that the machine learning is based on an algorithm that gets created up in our compute environment, but that gets delivered locally to the agent that's being installed here. It's a mathematical algorithm. At the end of the day, we're leveraging the CPU of this system to do what CPUs were designed for, perform mathematical equations. What that leaves you with is a very effective, very performant agent that not only can stop the threats that we see today, but also, back to that preventative nature of the agent itself, make sure that we can prevent threats that we haven't yet seen before. As you can see, the agent is now installed and has been enrolled with the management console. Now, you may have seen as I conducted that installation, I actually pasted an install token into the agent UI. That install token is a token that's used just one time when the agent is installed, and it's intended to authorize which tenant within our cloud infrastructure that agent should register itself with. Again, it's just used once and then thrown away, but that token in an enterprise environment would be embedded into the package itself, right? So that wouldn't be something that you would necessarily deploy or enter into the console or into the agent on your own. Now we're back to the management console, right? The management console has some intelligence in order to dynamically apply the policies to that agent that we just installed. This is all based on the concept of a zone. And really a zone for us is just a logical collection of systems. So as you can see here, I have a zone called our Rosenzweig's demo environment. That is my zone. And you can see all the systems that I use in my environment are members of this zone. In terms of that automation that I was talking about, zones can incorporate a zone rule. A zone rule can be used to add new systems to zones, to move systems across zones, apply policy to those systems, and then also from an administrative perspective, make sure that you can only see those systems that you have the rights to be able to see, and also scope the reports that you need to extract from the security environment. Let's go ahead and take a look, though, at a system that's been online for some time now, so we can look at some of the additional activity. We're going to look at a system that's named Barkley. Barkley is actually the name of my dog, in case anybody's wondering. But Barkley is a system that has been deployed some time, and it's a system that I use to actually demonstrate and detonate malware against this particular agent. And you'll notice one of the things that the console will show you is information about the device itself. You'll see information like the device name, what version we're running at, as well as some identifying information like IP addresses, MAC addresses, and so on. But most importantly, we'll show you all of the threats and activities that are taking place in this on this system. Now, the magic behind this is what I was going back to before, was the concept of prevention. We are a pre-execution technology. So you'll see that there's a piece of malware sitting here in quarantine, Kofter. You may have heard of it. It's fairly well known. But the way this process works is that when a binary attempts to execute, like this example with Kofter, we extract the features and characteristics from that file statically before it has the opportunity to execute. We determine then if that file is safe or unsafe by running those features and characteristics through the math model that I talked about before. If the file is determined to be unsafe, we prevent its execution and we quarantine the file, just like we did here. If the file is safe, we allow it to run and the user is none the wiser, right? So all of this really happens in about less than 100 milliseconds. And so it's extremely fast and really helps us really address one of the major problems that you see with traditional security solutions, which we call friction, right? And we want to offer better security with less friction, and that's what prevention can deliver. Now, in addition to being able to prevent threats on the endpoint, we also have the ability to leverage our experience with artificial intelligence and machine learning and extend prevention to incident response as well. And so our incident response use cases actually start with visibility, right? And it starts with the ability to help add context around threats that we prevent. And so you'll notice that there's actually a column here called Focus View. Focus View is essentially a breadcrumb trail. It allows us to determine root cause. We had that file called Kofter sitting in quarantine. As you can imagine, we're performing mathematical equations on the endpoint, and you or I probably wouldn't really understand what the outcome of that was, other than the fact that the file was determined to be unsafe and quarantined. But what we can do here is really operate almost like a flight data recorder would on an aircraft, right? Instead of monitoring all of the forensically relevant activity taking place on an aircraft, we're monitoring all of the security relevant information and context that's taking place on this endpoint. And you can see that it ends right here with this point in time, represented by a green shield. That's the point in time when we predicted and prevented that file as being unsafe and prevented its execution entirely, right? And you can see these were all the series of events that actually led up to that. The data is presented in a couple of different ways. You can see the swim lanes across the top of the screen. I think it's a really great way to help determine what that root cause is. And then we have these calling cards down at the bottom. It represents the same information you're seeing on the top in the swim lanes, but really enriches that information with a lot more context that hopefully brings us to the point, and we'll talk about this in a second, where we can actually strengthen those security controls by really having a better understanding of what's taking place in the environment. Now you'll notice as I work through some of these, and I can go through a timeline and see what those timeline of events were, but some of these attributes, let's call those artifacts of interest, right? That's what they really are. These artifacts some of these are shadowed with these white shadow boxes. Let's find something interesting that I can show you, and we'll show you what that is actually for. Now you'll see that over here, right before PowerShell is called, there is a outbound connection to this destination IP address. So you may be wondering, right, are there any other systems in the environment that are also talking to that destination IP address? And so what I have the ability to do is actually click on that artifact of interest, or at least the header for it, and run an instaquery. You'll notice there's also an instaquery option up here. We call this one down here a pivot query. They're identical except for the fact that I'm pivoting off of an existing investigation, and you'll notice that the search engine that results is pre-populated with the search criteria, the artifact, the facet, so that all I need to do is go back and assign this to a group of systems, again, tying it to a zone that I talked about before, and query the environment. This takes about 30 seconds for those results to come back. And during that time, I can continue to actually run through my investigation and actually run additional instaqueries as I'm looking for that while we're waiting for those results to return. Now, when results return, we actually have the ability to do a number of different things, right? You'll see that Barkley is sitting right here, and I can actually add artifacts of interest to the global blacklist, for example, and prevent their execution moving forward if for some reason we allowed them to execute in the first place. We also have the ability to lock down a device. This will isolate the device on the network, isolate it from communicating anywhere on your network or out. You'll see it's a time-based lockdown, 5 minutes to 96 hours, but you can always extract an unlock token from the console and release that device back onto the network prematurely. We also have the ability to deliver packages. We've embedded a Python interpreter into the service of our agent that allows us to extend the product in some pretty powerful ways. We do have some integrated response actions that we're delivering to our customers, mostly for the purposes of forensic artifact retrieval, gathering browser history, Windows event logs, and the like. But the product is extensible as well. So you can create your own packages, clone ours, and modify them. But the important thing is that the solution can evolve and grow with your business. In addition to deploying packages, we can also initiate a remote response. Remote response allows me to just simply interact with an endpoint in real time, as if I was sitting there running a native shell on the endpoint. I can run commands as if I was sitting right there, like an ipconfig, and you'll see all that would come up here directly in my remote response console. And an analyst can run as many of these as they would prefer concurrently. No problem running those. In addition to running commands, you can also send files and retrieve files. So again, you're interacting with this system in real time. Last thing I want to mention is that you can see that we have a lot of preventative capabilities. We have a lot of context that we're providing. Let's kind of wrap that around sort of the third use case for this capability, which is really around automated incident response. So it's really great that we have all of this visibility, as you would expect from any EDR solution. But what we also have sitting on top of all of this is a context analysis engine. The context analysis engine sort of ties all the things that I've been talking about together, right? It ties the ability to go out and detect and alert to malicious or suspicious activity, but also provides the ability to determine automated responses as well. We are a preventative EDR solution as well. And you'll notice that within each of these groupings within the context analysis engine, and some of those are developed by us and are through our own threat research, some are directly mapped to the MITRE ATT&CK framework, and some are driven by artificial intelligence and machine learning. But you'll notice for each and every one of these rules, we also have the ability to determine a response. Some of those responses are predefined for you, terminating processes, logging users off the system, locking the device down, some of those things we've already talked about. But again, automating and orchestrating your playbooks. And this goes back to that extensibility that I was talking about before, right? That ability to create your own custom packages, your own custom remediation actions, and your own automated playbooks that can be fired automatically, whether or not your device is connected to the internet. At the end of the day, the goal is, of course, to provide an AI-driven, predictive and preventative security solution. And the track record that we have shown has shown that from a predictive advantage perspective, artificial intelligence has proven that we're able to predict and prevent threats that we've never seen before, on average, up to 25 months into the future. Again, my name is Rosenzweig. I thank you for your attention.